Hello, good morning everyone. My name is Yash Jagtap. I am a DevRel engineer at Dataverse OS and I also work as advocate at The Graph. So here today's topic is about Substreams and introduction to Substreams. So let's get started. So these are going to be, we are going to see what are the basics of the graph because Substreams is a very technical topic, and to understand that, I'll just give you a brief introduction about what the graph protocol actually does. Then we'll see what subgraphs are. So that is something that is built on top of graph protocol to query the blockchains. Then I'll introduce the substreams and how powerful that is and what advantages it takes over the subgraphs. And then I'll do some comparison of both, and we'll see some basic boilerplate code. I'll walk you through how to build your own custom substreams. So basic prerequisites for this are some basic Web3 knowledge and some coding, very programming less programming experience. So I hope everyone here is accommodated with that. Yeah, so my question is, how many of you have built on top of Graph or Graph protocol? Cool. So I'll tell you why the Graph exists. So as you know, the blockchain data is scattered all around the world and the blockchain. So there's not a structured way to store that data. So that's why the Graph protocol exists in the first place. As you can see on the tagline itself, it says access the world's blockchain data. So what do we mean by that? As we know, there are a lot of blockchains and the future is definitely going to be multi-chain. So we want some mechanism to get that data indexed and query that data for better user experience and user interface. So that's why Graph is basically exists in the first place. So yeah, basically we can say that Graph is similar to what Google is in the Web2 world. So as you know, Google is the, we can also say Google is a protocol, indexing protocol for the Web2 world, because whatever you put in the Google, all the data is indexed on the centralized servers, right? So that's why whatever query you put in the search box, you get the instant results. So why that happens? Because all of that data is indexed in their servers and you can get that. So similarly, the Graph does the same thing with the help of the indexers and the curators and some nodes that they work on. So it's a decentralized network. So that's how they index and query the data. Yeah, so this is a general some transaction block, you can say. And the data is scattered. So you can say some part is transactions, some part are maybe smart contract calls. So, so what happens is, yeah, so these are the just basic outline. Yeah, so what Graph does is, it takes all of the blockchain data that is have for the particular smart contract or whatever we built and creates a specific, what we can say, the database for that particular subgraph and the entities. Yeah, so what is a subgraph? So subgraph is basically the main thing that we build to query these things. So subgraphs can be seen as the open APIs to query the blockchain data. So that is written in assembly script. That is a special type of TypeScript. And we use GraphQL to query the blockchain data. Yeah, so basically subgraph is the indexing layer we have. Yeah, so this is the current dApp architecture. As we can see, we have user interface directly, and for any data that we want to get, we can use the blockchain, right? But we cannot get specific type of data. For that, you need some centralized indexing services, or maybe you can make use of Alchemy or Infura or Dune Analytics if you know. So these are things that you can query through. But yeah, this is the major problem. So yeah, to get a, let's see here it's an example of getting token ID. So if you want a token, maybe some NFTs for a particular owner or owned by a particular address, you have to write this line of code that can be very daunting to us. So that's why the Graph comes into picture, where it indexes, it's the middleware for the indexing, it works as the indexing protocol between the user interface and the blockchain. So the same thing that we saw earlier can be done with the graph protocol in this way using subgraphs. So that's very easy, and that's why it gives better user experience as well. So you can see this slide zip of how the graph data is stored. Yeah, so there's a website called info.uniswap.com. So that has all the details about how the Uniswap, the key statistics, analytics of how the pools of everything that is created on Uniswap. So all of these things are powered by the subgraph. So these are some of the statistics of the graph protocol. So there are 400 indexers, then 11,000 delegators, to 2,500 curators and 800 plus deployed. I think this number might be updated now. And recently, we crossed a milestone of 1 trillion queries that have been served so far. Yeah, so everything is good, right? Like we were able to do everything with subgraph. So, but what were the problems that we can overcome to build some better developer experience and the user experience, right? So these are like some of the maybe cons for the subgraphs. So that includes learning assembly script. So as I said, assembly script is a special type of TypeScript, and that has some major barrier that comes to while coding as well. Then requires learning about brand new and complex protocol. As you know, graph is not something that is very easy to understand at the core level. So it requires some very knowledge of how how it works at each step. And then again, slow to sync a large subgraph. So as you can know, there are many subgraphs that index or query a lot of data. So as the data is humongous and the blockchain is always increasing, so it is slow to sync those subgraphs, and all it does is using RPC calls under the hood, right? So that's why it's a linear solution that it takes some less time. Then subgraphs are not composable. So you cannot use some existing maybe see modules from the subgraphs. So, but you can use existing subgraphs or create your own, but they are not composable. So these are some of the maybe cons for the building subgraphs, right? So yeah, so that's why this new technology or the Substreams was born. So Substreams is basically, as you know, it's similar to subgraph, but it scales massively. That's the basic crux behind that. So we'll see how it does that. So the basic method is it's a new method for indexing technology that was built by the Streaming Fast team. And the Graph protocol gave them a grant, and now they are the core developers for developing this particular technology. And the main thing, how it massively scales, is parallel processing. So as you know, the subgraphs works on the, we say, linear processing, right? So that's why it takes some time to sync those nodes and the data. But with parallel processing, you can compute at max various blocks, and that's why it scales massively. Then streaming first fashion. So what that means is that it's a continuous stream of data that you get. So that's why it also helps in what we can say, the composability and the modularity of that particular chain. Then this is one of the major barriers I would say for entering or writing substreams is right now it requires Rust to write those substreams, but extensive development is going on creating libraries in JavaScript, TypeScript, or any other language. So then composable and modular. So what I mean by that is when substreams are created, you can use the existing modules from the substreams and you can just create a basic flow of how your data should work. And then modular is, of course, that we can build on top of existing substreams and make use of those. And then insane speed. Of course, with the massive scaling and parallel processing, the speed increases massively. Yeah, so these are some of the stats that we've seen. So this is guy from Vincent, that's from Messari. So they have managed to index the whole Ethereum blockchain that is from the past 8 years, I guess, in just 20 minutes that was synced with the help of Substreams. But subgraphs, it took around like 2 or 5 days for that, but with Substreams, it was just done in 20 minutes. Similar case was seen in the pancake swap scenario. So in that case, it took 3 months to sync the data. So I think that's a huge time, like 3 months. We cannot wait for 3 months for that data to sync completely. So that was brought to 48 hours by the streaming fast team and using Substreams. So that's a huge, maybe you can say, booster for the environment. Yeah, so all of the data that is being processed and everything, we can see that as a part of ETL queue process. So as you know, ETL stands for extraction, transformation, and load, and the queue part is for query. So extraction for subgraphs, extraction is done through the graph node, if you know, and the graph node that uses RPC calls under the hood, and they index the particular blockchain data using the RPC calls. Then transformation, that is, we use, as I said, the subgraphs are basically the transformation part. We write subgraphs in here. So we write that using assembly script, and that gets compiled to WASM, that is the binary file that runs on top of graph node to index the data. And then the load part. So for loading part, the subgraphs makes use of the Postgres database, and it stores the data that is being indexed in the Postgres. And the query layer, of course, GraphQL is very easy, so it makes very good experience. Yeah, now we'll see the ETL queue, same for the substreams part. So extraction part for the substreams is done by something known as Firehose. So Firehose is also a streaming engine that takes care of, in the streaming fast fashion, as I said, the advanced parallel computing techniques, it's used, all those things to extract the blockchain data. And then the transformation load, as we have seen in subgraphs, in subgraphs, transformation takes place. So for the substreams, transformation layer is taken care by the substreams here. And something for the loading for the graph, we have seen there is Postgres, right? But for the substreams, we have something known as sinks. And what sinks does, it takes care, we can create any type of data that we want to load into using substreams. So that it includes Postgres, MongoDB, Kafka, MySQL, or even Discord and Telegram you can store and send to that. So this is something that then the query layer, of course, for the, as we can say, it was Postgres, so GraphQL was the very easy way to query the data. But now if you have a lot of, what we can say, the output to store our data and output, so now the query layer can be based on whatever you build as your loading layer, right? Yeah, so this is the, I'm not sure if you can see, you just zoom in a bit. Yeah, so we'll see substreams in action. So we have, initially, we create a YAML file for that. So that is the basic boilerplate code, that how we want our data to be seen. Then we have protobufs. So protobufs are generally how we want to structure our data. If you have built subgraphs, you might have seen the graph schema file or the GraphQL file that you built. So this is similar to that, the protobuf file. We tell how the structure of our data should look like. And then we have the WASM binary. So whatever mappings that we build or the code that we write that is going to execute or index that particular events. So that is taken care by the binary files, the WASM files. Yeah, and the output protobuf is basically whatever the data that is indexed or the structure of our data. So the output output protobuf does the similar thing. It creates the output for that particular maybe entity. Yeah, so I'll just show you, walk you through the code of how we go through building substreams. So just a second. So this is the basic substreams. This is the very basic substreams part. So first part, as I said, it's the YAML file that we create. So here, I don't know if it's visible. Yeah. So first we specify the version, then the name, that is pretty boilerplate. Then the protobuf. Yeah, as I mentioned, the protobuf, we have to create a file called .proto, and where we have to mention how the structure should our data should look like. And import path is basically from where we import. Binaries, yeah. So binaries are basically the logic behind the substream that we built. And we like use Rust for that modules. Then, yeah. So modules are basically the functions that are built inside the substreams. So we have a name module. We have given here a map block. and kind. So modules are of two kinds, store and map. So what map does, it is the basic extraction layer, or we can say the output layer for displaying the data for the blockchain. And the store part, what it does is it takes maps as the input and stores the key value pairs for that particular any sort of data that we want to query. And as you can see for the input here, we are seeing that the block is the input. So we are taking the whole Ethereum block as the input for that particular module. And output is a protobuf that is named block meta. And protobuf, as you know, that is the desired output that we want. Right. Then after substreams, let me just go back. Yeah, so I'll just show you the protobuf file. So yeah, this is the protobuf file. We have a message block meta, and these are the things that we want to look at. So that may be hash, number, parent hash, and the timestamp. And the main code, main logic of how substreams that building, that is similar to mappings file if you have written in subgraphs. So mappings.ts file is similar to lib.rs because we use Rust here. So as you can see, we are taking the whole map block function here. Oh, I'm sorry. Yeah, cool. So map block function, then we are passing the whole block through that. And after that, we are fetching directly the block number from here, and then block hash, then the parent hash, and the timestamp. So this is a very basic boilerplate substreams. Now I'll show you a real world use case as well. So that is the Uniswap one. Yeah. So basically, for Uniswap, you can see here we have protobuf as the uniswap.proto, that the how it should be made. Then the modules. So there's a one module called map pools created. So whatever pools that are created in the Uniswap, if you have made some worked with Uniswap or have seen how it works. So there are pools, liquidity pools that we can query, not query, we can make transactions through that. So yeah, so this is the particular module for that. So kind is map because we want to get data about the pools that is being created. And the initial block, this is the starting block for from where we want to index the data, because it makes no sense to go before that. We don't want data before this block because it doesn't exist. Then for the input part, we can see there's the block part because we are fetching again the whole block for this particular entity. And then output is again a protobuf named pools. So we have created that. I'll show you just in a second. Yeah. Cool. So these are the protobufs that we can see that there's a ERC20, the data, how we want it to fetch, then the liquidity, then the pools as we have seen for the map pools created. So here you can see that. So let's now go to the source folder, and yeah. Now let's just see how this working demo. I'll show you through a graphical user interface. So this is the Substreams versal that is being demo that is being created for the demo purposes. So we have selected the Uniswap version 3 Substreams repo, and these are the modules that are being created inside that. So you can see there's map pools created that I explained, and then these other modules. So now I'll start streaming that particular module. So as you can see, we have map pools created, and start block is the boilerplate that we have mentioned, and stop block is optional. So if you don't mention, it will show the data till the current block. So I'll just add the first 10,000 blocks and start this. So as you can see, it has already started working, and the blocks, as you can see, max parallel workers, that 10 working through 10 different processors, and it has already processed those 10,000 blocks. So okay, let me. Yeah, cool. So what that pools has, let's see inside that. So if you see, we have for the pool section, we have the address of that particular token, then the timestamp at which it was created, then the block number as well. So this is a Frax token that was created, and this is some another token that was used for the pool. So all of this data that we get, that we got it so fast. So with the subgraphs, it might have taken some time, but it was possible due to the substreams. Another major advantage of this particular using substreams is it gives you the visual representation of how your what you can say, the subgraphs or the schema file will look like. So there's a particular command for that called substreams graph. So that will create a graph for you, and that will look like this. Let me just show you. Yeah, so if you can see here, this is being created inside the substream. So that gives us the whole idea of how our structured looks like. I'm not sure. Yeah, it can be seen. So as you can see, the end part is graph out. So every particular, it's a convention that we use in Substreams that for the graph out part, we store all of the modules that we have created or all of the data. We store that in the keyfare form for in the graph out section, and we can query that data using load into anything that we want and query it from there. So these are the things that let me. We can also check for the ERC21. Let me just go here and graph out. So as you can see, as the entity changes, we get these streams work so massively. As you can see, it's continuously generating data and getting the results back. And you can see the inside these data that we have, what is being created and how we can use that. So yeah, I know it can be very daunting, the Rust part, because even I have some problems starting that, and I have just started learning about Substreams right now. So let's see how it goes. Yeah, so I think that is it for my presentation. Thank you so much. And if you want to, please.
Hello.
This.
So there was an amazing presentation workshop. So if any of you have any questions, you can raise your hand and I can, take questions.
Also,
Q&A session.
I'm not an expert at this topic, but I'll try to answer to the best of my knowledge. Yeah.
Anyone?
Please do slideshow so that we can scan the data also.
Anyone? Any questions?
Yeah, just touch the surface for this particular Substreams, but you can definitely go on for refer the official docs and join the official Discord to get more information and develop on this. This is going to be the next, I think, great thing for indexing.